Hello, everyone, and welcome to this Telit Cinterion webinar, Design for Resilience, Building Always-On IoT Connectivity. I am Amanda Flink, the Head of Global Events here at Telit Cinterion, and I will be moderating today's event. To explain our topic today, I am pleased to be joined by Jose Sanchez, our Senior Director of Product Management, IoT Connectivity and Services at Telit Cinterion. Hi, Jose. Thanks for joining today.
Hi, Amanda. Thanks.
Now, just before I hand it over to you to start our presentation, I have just a few quick housekeeping points for our audience. We will have time to answer some questions at the end of our presentation. You can submit a question by posting in the questions box, which should be located near the bottom of your screen here. Also, take a few minutes to check out the resources section today for some additional information. There you can find today's slide deck and a few other resources that are related to our connectivity topic. And finally, we will send out this replay link at the conclusion to all attendees here. So be on the lookout for that. And with that, Jose, I will hand it over to you to start our presentation today.
Great. Thank you, Amanda, and welcome everyone to this webinar. The topic of today is, as the title says, Design for Resilience. How to build an always-on IoT connectivity solution, right? So in order to get started, let's discuss a few of the issues that are common in and when addressing IoT applications that need resilience, meaning critical IoT segments. So we see segments that are critical in IoT with high sensitivity to downtime, such as security solutions, for instance, alarm panels, healthcare for medical response, remote patient monitoring systems, utilities, electricity, water metering, heat metering, and other applications such as grid monitoring that are related to critical infrastructure, but also other applications such as retail, like payment systems, vending machines, etc. So in all those applications, they have a commonality. They have high uptime requirements, require reliable but also flexible connectivity. In all those cases, even the slightest disruption can lead to SLA or service level agreement violations, and downtime is costly, right? Traditional solutions based on SIM cards that are not programmable and simple failover setups like dual SIM setups, they fall short in delivering global always-on services. The reliance on a single network access is also not enough to serve highly critical, highly demanding customers. And last but not least, if your solution fails, you need to send out technicians, and this is costly, right? They drive TCO up and will have a high impact on profitability. So what are these situations that might lead to connectivity disruption? There are a lot of situations that might lead to connectivity disruption, but here we're just mentioning a few that might be relevant to the audience, specifically, when we're talking about IoT applications. We see devices that are mobile, those that are border crossing, for instance. A simple situation such as crossing a border might render a device unusable because of, for instance, roaming restrictions in the country of destination, right? Other situations related to disruptions in the network. Cellular connectivity is provided by a combination of technologies, radio access network combined with core network and several support systems. If the core network or the radio access network for some reason fails, this leads to eventually outages, and those devices located in areas of temporary outages, they will have no service. And those outages, they are happening regularly. They might lead to very small disruptions of a few minutes, up to, in some cases, even hours of disruption. This is critical for any IoT application, and specifically for the IoT applications in critical segments that we just mentioned earlier. Another case that might lead to disruption, imagine device installation, right? Imagine a smart meter that is produced in a production facility where there is an end of line testing and done successfully, but then the device is installed in the field in a deep indoor location, or a location that's hard to reach in a rural area, for instance. When this happens, the device will simply be disconnected, and there is no other way of recovering it than, for instance, switching SIM cards, right? Or in some cases, changing, for instance, antennas, installing external antennas, etc., might be another option. So, a device installation is an issue, and might render devices unusable for some time until this coverage problem is resolved. So there are many situations that lead to connectivity disruption. But now let's take a step back and look at the technology. What has been the evolution of cellular network technology for IoT, and in particular, the evolutions that have to do with achieving resilience? If we look at a typical IoT setup, we have connected things of various kinds. In a 3GPP standard setup, we would have a SIM card that stores the credentials, the operator credentials, and allows secure access to a radio access network. And then we have a set of core networks and support systems like the connectivity management platform, the CMP, that offers an interface to end users to monitor performance of connectivity. So we have seen advancements in the last years that have improved resilience, and there are many ways to improve it. For instance, one way of it is by improving coverage, right? We have seen evolutions of cellular networks to support low power wide area networks for enhanced coverage and battery life in locations that are hard to reach or indoor locations, and thereby implicitly improving resilience overall. Now the latest developments related to satellite communications, NTN, as an extension or as a complementary solution to terrestrial networks, also will help extend coverage in hard to reach locations. But not only the radio access network has been improved, we also see improvements at the core. Core networks are deployed in regional instances to serve data sovereignty requirements, but also to help achieve redundancy. In case one core network fails, the device can connect using a second core network. Georedundancy. The core network is deployed across multiple servers in different locations to also add resilience to the mix. Multi-cloud redundancy. We are seeing this also reliance on a single the cloud vendor might be a problem. So we want to also deploy different instances of our core network also in different clouds with different cloud services to add redundancy. So on top of that, we are seeing the increase of in the interest of using AI and machine learning technology to offer predictive maintenance for core networks, thereby helping applications and also to helping and mobile network operators and mobile virtual network operators in IoT to manage core networks and to react proactively in case of issues. A future technology, well, one that is already available today and it's been starting to be deployed in specific critical industries, is network slicing to ensure quality of service for particular applications such as video broadcasting applications, first responder applications, automotive, etc. On top of that, regional packet gateways allow lower latency, so the implementation of the access point to the internet in a local way in each of the regional markets where the connectivity is being offered also improves resilience, as it improves latency and also overall reliability. And of course, security drives reliability, as we need to minimize the attack surface or to control the attack surface in order to provide an always-on service. So these are all advancements, technologies that have been implemented in order to improve resilience. But there is a certain point where this is not enough and needs to be tackled by also an additional level of resilience. We will look now, of course, also into the SIM technologies that are used and are available to achieve additional resilience on top of the technologies that we just discussed. The SIM technology SIM technology has experienced also a dramatic changes since the early days of the IoT roaming SIMs, where a single IMSI was used with multiple network access. This, based on direct or indirect roaming agreements, would give access to various networks in order to achieve resilience, right? But this was not seen as enough, and in certain critical applications, we have seen dual SIM solutions where customers implementing, or enterprises implementing dual SIM solutions were willing to implement a second or even more third or fourth SIM card in the device in order to achieve resilience in critical environments. So whenever a SIM failed to provide service with a specific mobile network operator, then the other SIM would take over in a failover configuration. Again, this means a second SIM card, higher bill of material cost, and also higher subscription or data cost. The evolution of that came with the Multi-IMSI solutions, where a SIM could host more than one credential, operator credential, and would be used in a redundant configuration to, first of all, achieve and avoid restrictions in specific countries, for instance, roaming restrictions in specific countries, but also to optimize the cost of providing global IoT coverage. This can also be used to achieve certain level of redundancy, having the disadvantage that it is typically proprietary solution. So Multi-IMSI is not really interoperable across SIM vendors, and it's also hard to reconfigure in the field through a standard mechanism, which is what eSIM brings. eSIM brings the ability to store multiple operator profiles on the SIM in a standard way. So regardless of the SIM vendor, these solutions are interoperable as long as they are certified by GSMA, and they provide, again, ability to offer redundancy. There are standard features defined by GSMA, as we will discuss in a minute, that help achieve redundancy by utilizing the SIM card and multiple profiles to achieve always-on connectivity. So this evolution takes us to the eSIM, and the latest eSIM technology and technology is what we call SCP32, which is it's a standard that has been a specification that has been released earlier this year by the GSMA. The SCP32 eSIM is an eSIM implementation specifically designed for IoT devices that do not have typically a user interface. They are autonomously running devices, this SCP32 eSIM can be used in a failover configuration. What this allows is to offer service across a variety of mobile network operator services and radio access networks in a simple way, and also in an interoperable way. So what we see in this picture on the left is an IoT device with a SIM card that has two profiles. Each profile gives access to a set of radio networks in a given country, and the communication established between the device and the IoT application backend via secure connection, in this case, for instance, a VPN connection. So if there is an outage, in an outage scenario, one of the core networks might be down for whatever reason, a technical reason, operational reason, and this leads to a disruption in connectivity. So the primary data path is not available any longer. That means that the device remains disconnected. The application stops to send data to the end users, and there is a potential connection or a potential service disruption. In this case, the SIM card using what so-called fallback technology now automatically detects this situation and informs the card that needs to switch to a fallback profile. This is a procedure that is defined by GSMA, and it is a standard procedure and can be used to recover in case of outage. This first step would activate the second profile, the failover profile, marked in the card as with the color green, and automatically this profile is activated. The device will reconnect using that second profile over the failover data path. That second profile gives access to another set of radio networks in that specific location, and it allows the device to reestablish connection through an alternative channel to the IoT application backend. This is completely transparent to the IoT application and to the end users, and the service provider sees a unified view of the connectivity always through a single pane of glass CMP, and gets support from the connectivity service provider through a unified interface. So why this gives an additional level of resilience? First, these cards are programmable, so we can add failover profiles with time, but we can also modify them as we wish throughout the device lifecycle. And this failover profiles, they can give access to a radio access network and a second core network that is not affected by that outage. This means that we will be able to recover connectivity for critical applications even in case of temporary outages. If the outage is over, the application can always decide to go back to the original data plan. So this is how we leverage eSIM technology to deliver an always-on service. So we at Telit Cinterion, we empower your business with solutions that include global SIMless connectivity, connectivity, resilient connectivity for critical applications in order to deliver reliability and confidence. And we base that in our end-to-end IoT expertise. So we are actually taking you through the journey from the design to operations and streamlining operations for fast time to market. When it comes to bulletproof resilient connectivity, our solution leverages latest eSIM technology and eSIM standards. So it is interoperable and relies on the technologies that we just described earlier today during the webinar. Just to give you a high-level overview of our solution, the Telit Cinterion solution allows access to multiple networks in a single country for the sake of redundancy. We offer also a redundant core network infrastructure with deployment in various regions and also georedundancy in each region. We offer SGP32 eSIM technology in dual profile configuration, exactly for the purposes that we just covered in this webinar, using SIM fallback technology for hassle-free operations. And we offer a single pane of glass CMP visibility that help fleet operators manage connectivity throughout outage scenarios. And it is also available via APIs, right? It can be integrated into an end system, third-party system via APIs. With this, we achieve extended coverage versus the traditional SIM configurations, quick recovery from outages, as we have seen, and design flexibility. The device simply needs to integrate the SIM, and it does not need to be modified. There is no need for code changes in the end device. And the SKU is a single SKU, so meaning that we can deliver a global SIM, single SKU SIM, but also we can integrate that into our cellular modules for an even more integrated design. And this is all pre-validated and pre-verified against our modules, right? So this gives our answer to critical IoT applications that need resilient communications, but this is not enough if we are not able to offer great customer service. So along with the technical solution, our critical customers demand customer service, which is first class. That's why we have 24/7 support, in US and EU-based time zones, and we offer around-the-clock support with dedicated account managers and a CMP that helps also the job by implementing monitoring tools and alerting tools to be informed of issues when they happen and be always alert. And we cover not just the SIM, but cover with our know-how, we cover the hardware, the cellular module, the SIM card, the cloud, and the core network. So our support teams have 30 years of experience and in this sector, including hardware, SIM, cloud, and connectivity. So all in all, this is why we think we have a solution that can offer the best resilient always-on connectivity for critical customers in the industries that we have discussed today. Yes, this is the main message I wanted to pass on to you today. So I'm very happy to answer your questions now. Thanks a lot for your time today, and now I'm handing it over to Amanda.
Thanks, Jose. Great presentation there. And we have gotten some questions. We still have time to answer those, so feel free to submit them. Just real quick before we start on those questions, though, audience, I am going to drop a poll on your screen. If you'd like to have somebody reach out to you directly, maybe you have a really specific question related to your application and you'd like to talk one-on-one, please just respond here on the poll and we will make sure to have somebody reach out to you. Jose, really quick, I am going to have you stop the screen share.
Yes,
and that should move us to perfect, a nicer view. Okay. 9:27. Okay. All right, we are just going to dive right in here. The first question I have received says, why do deployments based on traditional SIM cards fall short in delivering a global and always on cellular service?
Thanks, Amanda. Well, yeah, we kind of covered that already. I think we can, go a bit deeper into that when answering this question. I would say a few reasons, right? So first, lack of redundancy. So traditional SIMs are not redundant by design. I would say second, the lack of remote upgradability. The traditional SIMs are also not remotely upgradable. So whenever there is a change, you need to send out someone to replace the card. So that is another reason why traditional SIM cards fall short. The third one I would say in my list might be excessive costs, so bill of material costs. Traditional dual or failover configurations use two SIMs, two SIM slots, two SIM cards, two subscriptions. So this adds to the device cost. It's a significant percentage of the total cost of ownership that gets lost because of this.
Sure, makes sense. A lot more complex. Next question I have says, can you explain the main differences between Multi-IMSI and eSIM multi-profile technologies in the context of your presentation today?
Yeah, okay. Good question. I mean, this is really Multi-IMSI technology has been there for a while, and also eSIM technology. I would say the main difference at a high level, there are many others, but Multi-IMSI itself is a proprietary technology implemented by each SIM vendor. So this is something that makes that technology not interoperable. When you change the SIM vendor, you need to go through a process which is costly to re-implement the profiles which are inside the SIM card. So this is a bit of a technical detail for our audience out there. Maybe they say they don't want to understand or hear how the IMSI, the SIM card is built, but this has an impact, of course, to how mobile network operators and MVNOs specialized in IoT, such as Telit Cinterion, are providing connectivity. We would like to offer your customers a solution that's future-proof and that we can also easily upgrade in case it's needed. And eSIM gives us this tool today, which Multi-IMSI doesn't. Although to some extent these two technologies are complementary.
Sure. This question came in early during your presentation, but says in slide 6, why does the APN need to be reconfigured? Okay,
so yeah, if I remember correctly, slide 6 is where we have the diagram and we showed the fallback solution or failover solution using two profiles. So potentially each profile is using a different APN that is dependent on the connectivity service provider. So that is defined by the connectivity service provider. In the best case, the device should be prepared for such APN changes. In some cases, the APNs can be pre-configured in a sort of table if they are known in advance. But if they change throughout time, our recommendation is to take this into account when designing the IoT system and the device management system. And yeah, I can also say that we also offer device management solutions for IoT that help this. So yes, either you reprogram the APN yourself using your IoT device management system, or we can help you do that. But in any case, the APN might change if a new profile is used. And this is essential to recover connectivity. Without knowing the APN, the device cannot really connect to the internet.
Great. This one's kind of a follow-on maybe to that. How does the device know that it can switch back to the primary profile?
Well, yeah, that's a very good question, and it's maybe a little bit of it's a tricky question, because of course the answer here depends on the situation. And switching back to the original profile, you only want to do it if you know for sure that the outage is over. So that in order to know that the outage is over, you have various sources, right? You can go to the connectivity service provider, and the device can perform regular scanning of the network to identify if the network is available again. So I would say it really depends on the application. The symbol in this case will remain on the backup profile until it's indicated by the IoT device or the application, just not to ensure the connectivity is not lost throughout the process. We would also, what we typically do is to work together with our customers to implement a notification, and ensuring that they know when the application can switch back to the original profile and go back to the original situation. The SIM card can also be programmed to go back to the original profile after a certain time. And then if it again encounters an outage, it would again go back to the backup profile. So there are various ways to resolve this, but in any case, there is a solution.
So many options. I'll take just a couple more questions here. This one says, what is the average duration of the fallback mechanism until connectivity is recovered? Which I think you kind of covered this a bit, but maybe we can answer that one.
Yeah, the SIM itself is autonomous, and it detects a no service situation. There is a certain delay there, but typically, this is typically happening within seconds rather than minutes, right? So it's a process that takes seconds, simply because the profiles are preloaded in the card. So it's all happening locally, and yeah, so it's a pretty fast recovery, I would say.
All right. One more. Which scenarios are not covered by this solution and would still lead to a service?
Yeah, of course, no solution is perfect, and this solution also has some limitations, like any solution. And well, simply said, whenever there is no network coverage at all, situations such as hard to reach locations, far locations, like rural areas that are not covered by cellular service, or deep indoor locations, installations in places where cellular signal simply doesn't get there, even with a fallback profile or a backup profile and eSIM technology, you would not be able to recover service, right? So obviously there are situations where this solution is not gonna help you recover connectivity, but I mean, we believe that this kind of solution is just another small step to help any kind of critical IoT application customer IoT application enterprise offer an always-on service, and yes, there are always situations where even this is not able to help recover service, but that's that's life. There's always limitations, and we have to be able to live with that.
Yeah, perfect. Jose, I think we will wrap there. Audience, again, please be sure to check out that resources section for some additional information. Slide deck is there. We will be sending out this replay link if you missed any of this presentation today. And Jose, thank you so much for your time today. I really appreciate it.
Thank you everyone for listening and tuning in. Thanks.
Thanks, guys. Have a good one.